So students, what we are doing, we are taking case of a rod which is non-uniform and such that its mass per unit length, which is lambda, it varies linearly with x, and according to the expression, lambda is directly proportional to x, means lambda is equals to alpha into x, and this alpha is the constant here, constant of proportionality, and we have to find here the x coordinate of the center of mass, and of course we are going to find it as some fraction of this length, because that is the only variable, a rod of length L, that is the only variable given to you, L. Okay, so you have to write the answer in terms of given variables. And here, as you see, this linear relation means that if you draw a graph between x and lambda, you will get a slope, means a constant slope, means linear relation means line. You will get a line of this graph between x and lambda, and you can see here mathematically also lambda is equals to alpha into x, so y is equals to mx plus c, so alpha is the slope. So if we visualize this question, this rod, so this rod, because the mass per unit length is not constant but it is proportional to x, means x is the position. So if I am taking this particular mass, so then x is the position of this mass from the center, and its mass is of course dm, and dx is the length. So, but as you take another element over here, it will be more massive. Okay, so as you increase x, it so the mass near the left end, so the masses on the right side are more massive than the masses on the left side, right? So
Yes.
so we'll do this problem as we have done the earlier question, but here the twist is that linear mass density is not constant. So what is the twist here? This linear mass density is not a constant. Earlier it was constant, but here it is not a constant. So what we are going to do here, so same thing we are going to write, lambda is equals to m by L. Okay, so now lambda is equals to m by L, and lambda is not constant. So here lambda, what is the value of lambda? Lambda is equals to alpha into x, that's equals to m upon L, right? So this is what will the change. Now what is the formula that we have for center of mass? So center of mass, the formula that we have is x equals to, yes, tell me this formula right over here that we have used over here. Yes, yes, integral. Speak, students, you can speak along with me. Integral, yes,
DM.
XDM.
yes,
XDM.
x dm, yes,
DM.
x dm. So first of all we have to write the original formula. Okay, yes, divided by integral,
Integral DM.
yes, very good, integral dm. Okay, so now here also same thing we have written, that this dm was equals to, in this case also dm was equals to lambda dx, isn't it? Yes. Okay, so we can replace this dm with so what is dm, dm here, so we can write it as lambda equals to dm upon dx, right? Yes or no? And we can write dm as lambda dx, and the value of lambda is, we know that this is alpha dx into this. Okay, so that's my linear mass density. Okay, so put these values over here in the same way as you substitute. Students, can you calculate it? I'm giving you 1 minute. Come on. Try to do it. So let us write it little bit more systematically. So this lambda is nothing but alpha into x, and this m, if we take small element, then its mass will be dm and its length will be dx. Okay. So what is the value of dm here? So here also you put the value of dm, right? Because here also, so you have to put the value of dm only. So put the value of dm only. As you put the value of dm over here, the only change is that now your dm equals to, so dm equals to alpha x into dx. Okay.
Yes, sir.
Come on, do it fast. So that's equals to अगर आपने खाना नहीं खाया मम्मी तो खाना खा लो, वो वेट कर लेगी, वो कोई दिक्कत नहीं है वहाँ पे उसने बहन ने। Done it, students?
So what will be the answer? L by 2 coordinate of x.
Yes, answer of
Sir, you are not audible.
ये मेरी क्लास डिस्टर्ब होने लग रही है, मैंने क्लास रोक रखी है अपनी, समझ में आई? पिछले 5 मिनट से कोई चाबी परवा को देनी पड़ेगी, क्योंकि मेरे ऑफिस में बाकी चाबी अगर कुछ खोलना पड़ेगा तो, अगर वो मांगे तो दे दियो, ना मांगे तो अपने पास रखो, कोई जरूरत ना कुछ भी खोलने की। मैंने अपनी क्लास रोक रखी है, मेरा पापा भी जावे है, तो फिर ये बोलना कब बंद करोगे मैं पूछूं? So students, yes Mansi, have you got the answer?
So is it L by 2?
See, of course it is not going to be L by 2 because it is massive on this side. So this was your L by 2, suppose here. So of course it will be somewhere here, because you can see it is more massive here. So weighted average
Sorry.
we calculate. Okay. So obviously it will be towards this side of L by 2 because it is more mass over here. So center of mass will be more here on this side, somewhere here. Okay?
12 by
Is
3.
it 12 by 3? 12 by 3.
No. 12 by 3 means what? 12 by 3. So it's 4. 12 by 3 means 4. So 4L, you are going outside? No.
No, sir. 2L by 3.
2L by 3, yes. 2L by 3 is the correct answer. 2L by 3. So it's better to say 2 by 3L. Okay? So that's somewhere here. So 2 by 3 means 1 by 3 and then 2 by 3. So this is 2 by 3. Okay? So 1 by 3 and then 1 by 3 and 1 by 3. So divide it into 3 parts, this length, and here you'll get 2 by 3. Okay? Good. That's good, students. Good learning. So let us put the value of this dm over here. So earlier you were putting only this lambda into dx, but here this as this lambda is equals to alpha into x, so let us put it over here. So x into alpha x into dx divided by, so simply putting that value of dm from here. Okay, so put this value of dm from this expression to here, and this dm, so here also you can put the same value, so that is alpha x dx, and this comes out to be, so take the constant outside, so alpha is the constant. And now tell me where this which dx you are going to add. Dx starting adding from here, here, all the dx you are adding, so 0 to L. Okay, so this limit, lower limit and upper limit, you want to write which dx you want to add it, right from 0 to length, all the dx. Okay, so alpha is constant, 0 to L, and x, so x into x is x square into dx divided by alpha into x dx, and this comes out to be, so alpha will cancel out, so alpha will be cancelled, and now what is x square dx? So you know this formula, right, of the integration. So increase the power by 1, so here it will be x cube and divided by, yes, this x cube divided by 3, yes, and 0 to L. So we have used this formula. So increase the power by 1 and divided by that power. So here also, of course, this is 0 to L, this dx. So this comes out to be, like we have done this integration, so this is the same integration here. So you are going to get the same value, L by 2 at the bottom, right? So this is so same steps you are going to repeat here. So it's integration, x here power is 1, so increase the power by 1 and divide with that power. And see, students, you can notice one thing, that this integral sign and this dx both are removed, so just increase the power by 1. So here also all these two things means this dx and this summation, this integral sign, so these two things are removed as you done this. So and limits will come over here, this limit will come over here and this limit comes over here. Is this okay?
Yes, sir.
Okay.
Yes, sir.
Good. So now the limits 0 to L, and that comes out to be, so put x equals to upper limit, so that is L cube by 3 minus, put the lower limit, so lower limit is 0, so 0 cube divided by 3, and this whole divided by L square by 2 minus 0 square by 2. Okay, and this comes out to be, so the coordinate that you are finding, so the x comes out to be L cube. Students, here also of course this L cube upon 3, and this divide will become, so if you will do, so reciprocal of so this will be 0, right? So reciprocal of L square by 2 is 2 by L square. Okay, and this so 2L here, and so 2L here will cancel out, so only 1L will left, and this will be written as x equals to 2 by 3 L. Okay, so that's our x coordinate, so that was our target. So this is capital X, right, this distance, and that is equals to 2 by 3 L. So writing the center of mass in terms of length, in terms of fraction of length, this is what we have done. So students, I hope you have understood this. Please write it down. Hurry up. So next question is center of mass of a right triangle. So you can assume this right triangle as here, this way. So we need to find the center of mass. So we'll do this problem as we have done the earlier problems. So now what about the density? So here it has uniform density. uniform density, and that density is rho. Okay, so because we have area over here, so this is also a case of lamina, you can say. Okay, so it's a flat surface with no thickness, almost negligible thickness, you can say, and that is equals to mass, total mass upon total area. So that is what density is, mass upon area. So we have continuous distribution of mass here again, and we need to use so whenever we have continuous distribution of mass, we need to use the integral formula. Okay, so this is your 0 and this is your x-axis, you can assume. This will of course your y-axis. So x-axis and y-axis. Students, keep on writing along with me, okay? That is why I am writing slowly, understanding and writing it along with me. And here also you will take a small element whose mass will be dm and its thickness will be dx, okay? And of course it is at a distance x. So this distance is x from the origin. So we also need to take, so in the last question we were taking it as L, length L, but here we will be taking it as this base is A and this height as B, okay, because we need to find the area here, okay? So we need to, so this right angle triangle, so area is half into A into B, okay? So area of triangle, we all know, so that is equals to half into base into height. So that we are going to use. So students, we know the area here, so instead of length we have area and we have the formula for the area. So I don't think that we have any problems. So here also we will write it as rho equals to dm, and here we will be taking it this dx, okay? So let us start that, but in all the questions like we have calculated the dm, so here this dm, what this dm will be equals to. So if this is at this distance is, you are taking it as x, so obviously here you will be taking it as this distance y. So this coordinate is xy. Right? Now so normally when you are dividing this triangle into narrow strips, so there will be narrow strips, and all of means their width will be dx, and the height is also varying here, so their height is y. So if you are taking this strip, then this length and this height you will be taking. If you are taking next strip, then this height and this length you will be taking, right? This length and this height for this. So now y is of course the height of the hypotenuse here. So what will the mass of each strip? So mass is mass, we know that here will you be taking area or will you be taking the volume? So the density is given by, if there is thickness, students, if the thickness is given to you, then you will write here volume instead of area, okay? And if there is no thickness, if there is lamina, then you need not to write here T. So then the thickness is almost negligible. So it's up to us. But even if there is thickness, let us take the case of if there is thickness. So what will be the change? So the thickness is also there. So instead of A, we'll have volume. If this is not lamina, if this is simply right triangle with some thickness, so right angle triangle mass and it has some thickness also. So let this thickness be T. Okay. So what will be the volume of this? If I taking this small mass, what is the volume of this small mass? Like we were taking the length here. Okay. So what is the volume? So volume will be dm upon rho. So that is equals to, so T is the thickness, so dx into y. So what is volume? Volume is equals to length into breadth into height. So this has dx is the length and height is y, suppose. So dx into y into thickness is T, right? So that's your dm. And so dm will comes out to be, so dm will be equals to rho into y into t into dx, right? So this will be our dm. Okay.
So why you are not taking dy or dt?
See, why I'm not taking see, that's a very good question. See, thickness is uniform. Okay, thickness is not changing. That's the first point. Thickness is constant. And the second point is that I will be finding the answer only in terms of, because I am taking the strips. So here my answer will only be in terms of A, like it was in terms of length. So the answer will be only in terms of A. So at which point? So center of mass. So yes, I need to change the question, means x coordinate only I am going to find here. Okay, not the y coordinate. I am going to find the x coordinate. Okay.
But sir, y is also changing.
See, that's what I am telling. That's a very good question. Y is also changing. You are absolutely right. But I am finding x coordinate only. Okay, that's my question. My question is to find the, okay, you can assume this as this is a like metal sign. Okay, this is a metal sign, and this metal signboard, if you have visited some restaurants, they are hanging just from the top, this metal sign. Okay, might be written some information, that is the counter number 1, counter number 2. Have you seen this hanging sign? Yes. Okay, hanging from the roof. So I want to find out that at how much distance from this left end I need to paste it over here at the center of mass, so that it will not be tilted, it will be straight. Okay. And in future we will also study center of gravity. So center of gravity here is the same point as center of mass. So you can assume this question to visualize it more. You can assume it this way. Okay. So what is this length where I am going to paste this vertical string so that it will remain in horizontal position. Okay. Now the question is more appropriate.
Yes.
Okay. See, another point that you have asked is, it's a very valid point, that sir, why you are not wearing, why? Very good question. See, For this dx is so small, it's negligible, its length is not that much. For that dx, this y is constant. For that particular strip, y is not changing for if you are taking dx, what is the value of y for dx? That's a very good question you have asked. Let me discuss it. So this is infinitesimally small strip that you have of the triangle. Okay, so this is infinitesimal. So the dx is tending to 0. Okay, so when dx is tending to 0, you are making it more, means as thin as possible. So almost a line. So when there is a line, still it is dx. Okay, but when this is a line, here you will get a particular coordinate, that is y. Like here you are getting a particular coordinate, that is x. Okay, so I'm finding the volume of this. So what will the volume of this? So volume of this will be dx into y. So I'm writing the volume here, right? So why will I write dy and dt? What is the volume of this strip? What is the volume of this mass dm? So volume of this mass will of course be length into breadth into height. Okay, so this height is if this is the length is dx, means length is y and width is dx, and the height is t, means here the height is thickness is t. Got it?
हाँ सर, थोड़ा
See, tell me, you have this metal strip. Okay, tell me the volume of this strip. Okay, you tell me, what is the volume of this strip? This is dx, its thickness, its height is y, and its width, you can say this is the width is dx, length is y, and height is t, thickness. What is the volume? Tell me.
dx into y into t.
So this is what I have written. Dx into y into t. Okay, students, we will leave our class over here and we will proceed with this because the time is over. So we'll proceed because this concept, I know this is a new concept for you and it will take some time to grasp it and we are short of time. So I'm ending the class over here and I will start from the same point tomorrow.